Hello, welcome back, and this time around we're going to do some automatic testing against a database, focusing on a test database, not the, we could call it production database. I think that's the word I'm going to use. So two different databases. We'll discuss in a moment what the differences are. So current status is that I have some automated tests. I might call them unit tests, but I'm sort of starting to test more than just single units. I don't know if there's a strict distinguishing difference. Anyway, we have the tests. They call methods on the service interfaces, so task service and user service so far. And we have the service implementations, and they use data access object interfaces, which are currently just some mock classes, which means that we are using a fake in-memory dummy database. It's just a list of the objects. So what we want to achieve is swap that out with a PostgreSQL, capital S, data access object. So actually the real implementations which can access a Postgres database. And in your semester project, you might have one database that is shared among you with some data that you're all sort of working on. And it's very inconvenient to do testing against that database, because maybe you need some data that someone else then reworks in between your tests and so on. So you need a database where you have full control. So we're going to create essentially a clone of this database. So we have one, I call it production, but this is the one that is shared between all of you. This is the one that is the source of truth, or whatever, truth. And then you have a clone which has the same tables and so on, same schema. It looks identical, but the data is different. So that's the idea. Maybe what I often see is that you host your database on elephantsql.com, because then you can all access the same database, which is pretty convenient. But then you, in this case, what I'm aiming for is to have a personal database on each of your own laptops, which again has the same structure, but this is the one we test against. And the only difference is a constructor argument. That's what we're aiming for, which says connect to either localhost or connect to some online cloud hosted whatever. So this test database, we reset it between each of the tests methods, and then we set it up to contain the exact data that we need. So this here will be cleaned out and reset and rebuilt for each of the tests. That also means that it's going to be, I assume it's going to be slower to run the tests against the actual database rather than just the test against the mocks. So we want to perhaps reduce the number of integration tests that we do. So initially we're going to test from here. My tests are going to call on the data access object interfaces, and then we're going to add the service layer, and then next video, I hope, we'll look at the network. All right, so current status is, this is my setup, my class diagram. My tests are driving the system through the user service and task service interfaces with the methods. Most of them, some of them, half of them perhaps, not deleted. These, half of them I guess are working, implemented down to the mock DAO. So we have a path through the system, and now we swap out this layer for the real thing and see how that goes. So I'm pretty excited about that. That's going to be fun. I have some thoughts, some plans. We'll see how that turns out. I have thought about how to approach this, and I have two ideas. We'll go with a simpler one, but just to discuss the other one, maybe you want to go with that one if you are ambitious. So I'm going to define the DDL, so that's the data definition language of how the database is implemented. So that's all your SQL statements of create table, all of those, right? They're going to be in a single SQL file, and it's going to be inside my project, so I can keep that under version control. And it will contain the initial creation code for the database. So initially I'll just create the user table, but then I know that I'm going to need more, for example, the project and task and subtask tables, and I will update the DDL file with the new stuff. So the idea is that we aim for not having to delete the database every time, the production database, but just expanding on it. We will add new tables, we will add new foreign keys if needed, we will add new columns to existing tables if needed. So that's the approach, and we have everything under version control if I keep it in my project, this SQL file. So that's convenient. Approach number one is that I create the test database with the DDL file sort of manually through, for example, data grep. And whenever the production DB changes the database, I update the DDL file, I run that against the Elephant SQL hosted database, and then I also run it against my test database. So the test databases you each have on your own computer, each member in your semester project group. And then every time we run a test, we will clear out the tables. So the tables will remain, but we will just clear out all rows, so the tables will be empty. So this is before each test, and then we insert whatever data we need. If I need to test that I can update an existing user, then I need to insert a user that I can update against. So there's some manual work here. Every time the DDL changes, I have to sort of push those changes or apply them to the test databases for all group members. And you need to sort of communicate so that you don't have tests that then suddenly fails. So whenever someone updates the database, you need to tell the others that they should update their test database. Approach number two is to use the actual DDL file to create the test database. So whenever the production database structure changes, the DDL file is updated, and it contains all the code that is needed to create the production database from scratch. So it will contain the initial create table user with 1 or 2 attributes, and then later perhaps it will have the alter table user, add column commands, and it will have the create task table, and so on. So the idea is that if I were to remove the database entirely and run the entire DDL file again, then it would be recreated to the state that it needs to be. So instead of having to manually apply changes to all test databases along the way, we would entirely delete the database, or just the schema. Actually, I call it database, but in the database you have schemas, and the schemas are the ones we're looking for. We could divide it into databases, I guess. In DBS calls, you will usually just use different schemas within the same database. But anyway, we drop the database or schema, so everything that we have for the database of the system is removed entirely. Then we just read the file here and then use that SQL and just execute it against the database, so it's recreated from scratch every time. And then we can insert the necessary data. So that means whenever your production database needs to be changed, you update the DDL file, and next time you run the tests, the test database or test database schema, whatever, test schema, the database test schema. Anyway, that will be up to date, so you don't have to do that manually. But that does require that you sort of read this file, which should be simple enough, and then you execute the SQL against the database, which should be simple enough, but we'll do the even simpler enough approach first. That one is what we're going for. So we're going through a few steps, and first I need to create the database and keep my SQL file in a resource folder. I'm going to download the Postgres driver, the JDBC driver, which we need to import into the project. And then I just need to make sure that I can actually contact the database. So I'll just write a super basic test. And then we start with the user DAO and do some or all of these. Create, find, update, perhaps at least, would be nice to get in place. Because then the rest of the methods and also the task DAO, I think I will do that later on when we can do a sort of full acceptance test of the server. Save that, because that's going to be interesting. So this is our plan. Let's give it a go. I'll start by opening DataGrip. Well, actually no, I'm starting by opening IntelliJ because I need to define my SQL file. And I think I will put that in some server resources folder. I think I can create a new directory called resources. And I should be able to mark it as resources. I don't know if this is actually necessary in any way. Resources root, whatever. And in here I will create a new file. I will call it basic server architecture ddl.sql. Yes, add to Git. And it probably actually recognizes it as SQL. And I can change the dialect here, so I could actually write it directly in IntelliJ. But I just open write. I'm used to doing that instead, so I know that it should at least behave as I expect it to. So here's writer, and just find that again. I want to take this file. Right, open it here. Okay. Let's see how this works. So first we need to create schema. See if I can remember DDL. And what do we call it? We call it BSA test with an underscore. And I need a session, whatever. Can I create a new session? That's probably fine. So that worked. And let's just see if, yeah, so that's automatically updated. So the file here is reloaded. Wonderful. So I have a schema and I will need my first table. Create table users. User. And like this. And my user has an ID which is of type unique, universal unique identifier. And I don't know if there's a way to translate that easily into the database. Do we have something here? Okay. Alternatively, the unique identifier, see here, it is just a string, more or less. Let's just do a DAO tests, user DAO tests. Yeah, and if we just go quickly here, test public void test UID random UID, and it does return an object to me. And what do we have? Stop here. It's just if I were to debug this just to show you what it is. Then I need a breakpoint to debug anything. Clever thinking. So if we inspect this one, you can actually see. So it's a fixed length, I believe, randomly seemingly random string of digits and numbers, and there's something about you know, information about my hardware, I think somehow, and my IP address perhaps, and my, or it's in a MAC address, and timestamp and some random stuff. So overall, this will be constructed by information that is unique to my computer. So that's the universal unique. You can look up how it's actually done if you're interested. But if we just try out, here we can, and if I go to string, right, I get that, returned to me. And I could also say UID from string. So if I actually take that string that I got, and then I can create a new UID. So I could just take the actual string representation and put it into the database. And I don't know if this works. We'll see what happens. It's an object. It feels weird. Anyway, I have a username as well. Just call it varchar. What's the length? I don't want to have any rules in my database actually, because then I have duplicate logic. So let's just go with this one. Create table user. Yeah, it's been a while since I wrote DDL. Is it because I have to do it like this? Oh. Okay. Okay, syntax error. The is a reserved keyword, so it should be quoted. Okay. User. Like this. Okay. But that's probably going to bite me in somewhere if I have a table that's Okay, we'll go with this. And I forgot to set the schema. You can see I'm working against the public. So set schema BSA test. There we go. So now I'm working against the BSA test schema, and that means if I create a table, then I have my table. Okay, user table, nothing in here. Good stuff. So that is, first step, create the database. I don't want to do the task and all that yet, so that's it for this time. Then we need to download the PG driver. So in order to connect from Java to the database, we need a Java database connection driver kind of thing, and Postgres has their own. So it's some third-party library we import into the project. And let's go and see if we can find that. All right, I have my browser. We just go Postgres JDBC driver, and there should be some official site. And I guess the big fat download button is a good start. Java 8. Okay, so obviously if you were to be using Maven, then you just include that in your Maven, whatever it's called, file, and then it's easier. I have to manually download this and import into my project. So let's see if this works. Just put it somewhere important. Relevant Java projects. Postgres 42.6. Yeah, totally keep that. I trust everything. Okay. And then back to IntelliJ, right? And we want to add it to this one. So we say module, build module, or module settings. That sounds good. Modules, yeah. And I want to add a dependency. You can see I depend on JUnit. That's fair. I have a dependency to the internal module server, so that's also expected. And it is a jar directory, and we are in here. And I have this one. Okay. So let's see. And we will just do a quick test in here. So this one, test JDBC. DBC connection, right? So let's see, how do we do? All right, so I imported the Postgres driver to the project. So now we just have to use it, and we say driver manager, register driver, and we say new org postgres driver, like that. And this one will we can't really do anything if it fails. We just throw and let the test fail. That's fair. And then we want a connection, so we say Java driver manager get connection, and I have to give it all kinds of information here. So first the URL, I guess, so it's JDBC, and we're using the PostgreSQL, and I'm connecting to localhost. So because that's my test database, but if it was Elephant SQL, you would use a different IP and port number here, and port number would be the default one, 4532. And then I had that schema that I created, BSA test. So if I just want that to be the default one, we say current schema equals BSA test. And then I need to provide a user, and mine is just default Postgres, and then password, super secret, equals database. And this one gives me a connection, and that's a good start. That should be able to access the database using this. And I want to use try with resource catch something eventually. We'll see. Exception E. So if something fails, then the connection is automatically closed to the database, because we want to close the connections whenever we're done using them, so we don't drown the database in connections. Okay, so super simple initial test. I just want to see if I can insert manually a user into the table I created in Postgres. I have my user table here, and we do that by saying connection prepared statement, and here I have some SQL. Let's define that. String SQL is equal to, and we want to insert into, and I have to use these because it's use and there was a reserved keyword. Insert into user values like this, and then the question marks to provide arguments. Okay, so I want to set the first argument. That's going to be an ID of type. Can I see that here? User columns, UID. So we say, I need a prepared statement first with the SQL. Oh, I have that next. I'm totally messing up here. Okay, that's my statement. Yes, statement set. The first one is the UID, so that's actually an object, and it's the first argument. So we don't zero index here, and we just give it a UID.random universal UID. There we go. Statement set. The second one is a string, right? String, and just call username. And then we say statement execute, and that should take it to my database. And if I just remove the catch, there must be some of these. Execute throws SQL exception. Okay, so that's what we want to catch. SQL exception X, and then I can do whatever with it. Handle it. It's not relevant for this example. Okay, if I run this, hopefully we get to insert something into the database, just to make sure that I have stuff in place. Always exciting. Okay, nothing fails. And my table, refresh. No. So something fails. Should probably run stack trace, right, just to make sure here. Fail. BSA test. Did I, what do I call it? BSA underscore test as a schema. It's not a slash. It is a question mark. So we say, okay, that's where my database is located. Next one is I want to go into, this is my database. These are my schemas. So this is the database I want to use. So I say slash postgres. And then we put arguments like this. So localhost postgres database, that's the name of it. Yeah, postgres. And current schema is a test. Let's just try again. All right. Let's see. And I actually have a user, my first user. Wonderful. Okay, so this totally works. I can contact the database, and that's pretty neat. So what is next? Right, here we are. Verify basic access to database. Start with user DAO. So I have to create a user DAO that's actually the correct implementation, sort of. And let's go ahead and do that. So up here, server, I have to import the JDBC driver to the server as well. Right, server, jars and directories, load. Here we are, and I just put it in here. Okay. So data access, exceptions, user, task. Maybe we will create a task, and this one move up here, refactor, and we do the implementation first. So we say user postgres DAO. Here implements user DAO, and that means we need to implement all the methods. Okay, so they don't do anything. So that's a good start. Let's try our first test. This one is sort of breaking things. If I run it, we'll just comment this out. I don't want to run this every time. That was just the initial test to see if things worked. So which method do we start with? We want to do the create public void should insert user and calling create method, I guess. Into test database, whatever. And we do the before all, before each public void. So set up DAO, and I have a user DAO is equal to new user postgres DAO this time around, and we create a local field variable. Contradictory local field variable. Create a field variable up here so I can use it down here. We also need that public void clean up database method, right? We'll do that at some point. Do that afterwards. Should insert user into test database. So my user, I need to create a user. So let's say arrange act assert. The range is to create a user. Yeah, import and new users. This is the user that I want to insert into the database, and this one needs a unique ID. So we say UID random ID like this, so I can reuse it later on, and a username. Right? Isn't that what we need? And a password. Okay. Right. Let's steal one of those passwords. I forgot I had all kinds of logic for those. So where's a valid password? This one, I seem to has actual values for username and password. Right, that's okay. Uppercase, lowercase, number, and symbol. So password. All right. So obviously I'm going to have a problem, but let's write the test first. I don't have that column here. So that's the setup. The act is then user DAO create user, and the assert would be to actually extract stuff again. So it's a bit complex, I guess. Do I need to do this? I could probably move the this part. I could probably move up here. Let's see. Register driver. I just cut. Okay. So assert. We get a connection. Yes, I want. Now I want to query. I want to get the user back out again. So let's say select star from user with those. I don't know if I need the final, probably. Prepare a statement. There are no arguments in this one. Statement execute query. And that gives me a result set, and then it's something like while result set has next. What do I do? Result set get object on column ID. Let's see. I don't actually know how this works. And the object is the ID. Do I have something conflicting here? Okay. Retrieved ID. I know this is going to be UID at some point. Let's just see if this works. Result set and then get string from, what did I call the column? I called it username. Okay. All right. So these matches and the column. I want to get the ID column, the value of that. I want to get the value of the username, and eventually I should get the, let's just call it retrieved username, and that means I should actually have these as variables so I can match them. Yeah, and we do actual ID and all, no, not that one, actual username, actual password. Okay, so I can match whatever I retrieve to the actual stuff here. And then we also want the password back out again. String retrieved password, result set get string password. So I don't have this column yet, so I have to alter my tables. Let's see how far we get. Select star from user. No data sources are configured to run this SQL and provide advanced code. Okay, whatever. Let's see what happens. Nothing happens. Okay, it's compiling. I assume it fails down here, but hopefully it fails in this line. The column name password was not found in this result set. Okay, so it does fail down here. I do actually get something back, so we could, just to verify, would be fun. What do we get? We have retrieved ID. Does that match? That's probably the same. And we have retrieved name, username. Okay, we are off to a pretty good start, I think. But I need to alter the table, right, in my database here, and add a new password column. So I don't want to drop it and redo it. I want to alter it. So let's just say here version 1. Then we can, I don't know, maybe this isn't really relevant, version 2, and we want to alter the table. So Let's see if I can remember how that works. We say alter table, the name of the table user, add column, and we give it a name, password, and it is of type varchar. Again, I don't give it a limit. I mean, often we could say like 250 or whatever, but that's a constraint I want to check in my business logic layer, the services. So let's see, I'm still running against the BSA test schema, so that's good. And let's go with this one. Disable. Totally worked. And I have a password. Okay, let's remove this one again. Yeah. So what did I actually do? Username. I haven't inserted anything. So this should have failed. Okay, let's just go again. I shouldn't actually get anything back, but this was just from the previous test up here. So let's run it again, just to make sure that we have a red test, so we are allowed to do stuff. And I haven't asserted anything, of course. How do we do this? We say user. Yeah. No. Do I just assert in here? That feels a bit weird. Okay. Assert equals. No. Oh, sorry. I want to check all three. Right, so we say assert, and that means I have to copy that thing again. Here, all my assertions. So I have access to those methods. Import static, yes. Assert equal, no, assert all. And I could give it a string heading, but I could just give it multiple lambda expressions. Assert all, we say assert equals actual username, retrieved username. Okay. And I also want to assert that this one, assert equals actual ID and retrieved ID and actual password and retrieved password. So these are my assertions. Okay, let's go again. And of course I have nothing in my result set, so I don't even get in here. So that's something we should assert as well, I guess. A bit more. Okay. So true. Result set, can I see the size? Get fetch size larger than 0. Let's see. So that means there should be more than one row in here. Hopefully. I'm asserting a bit much, but I think that's okay. Yes, totally failed. And now it actually fails in line 50, 65. Good. So I have a failing test. And now we can actually start doing this part. So create user. Well, I need first a constructor. Yeah, because I have to. I think I have to do this. And I think I also need. Yeah, I can. Yeah. And we need a private string connection string and private string username, because that might change, private string password. Okay, so these three are passed in from the outside. right? I give them here. Yeah. Because then I can modify the connection string, right? That's the one which says that we connect to localhost. But I want to be able to say connect to Elephant SQL. So whenever I instantiate this in my test cases here, I will say this, right, like this. Yeah, so that's my test case. But when I instantiate it in my main method for the server at some point, I will provide a different, you know, the username for the Elephant SQL, for example, and the password. So now we can use the same Postgres DAO, but connect to different databases. So that's pretty neat. Okay. And then create user, that's the one we're working on. We say I have that, right? Just copy paste this and rework it as needed. So first we get a connection, right? And I don't want that. I want connection string, I want username, and I want password. And I feel like this is something that I'm going to do a lot, because in each of these I don't want to get a connection. So I will refactor this into a method and call it get connection, like that. So now it's just one place. And then I have my SQL, and I need another argument. And I have to import the prepared statement. And the first one is the ID, which is provided by the user. So we say user get ID, and this one is the password, username. And then I need a third argument, and we call it get password. Insert into user with those. It's annoying with this warning. Can I change dialect to? Anyway, doesn't matter. If I get an exception, I think I will throw new data access exception, because I have that, and we just say x.getMessage. That's probably not going to be super convenient for whoever user is going to see that we have a primary key constraint conflict or whatever, if they don't know anything about databases, but this is at least slightly better. So I want to catch the SQL exceptions rather than just throw them, because if I throw them, let me show you what happens. Catch. Yeah, and then I have to say add method is inherited. Yes, and if I do this, I'm going to break all kinds of things. So if I go to my user DAO, you can see it throws SQL exception, and that means I have to manage that in my user service implementation. You can see I have an error here, create user. Now I have to try catch an SQL exception. So let me just find my slide. This one, for example, I have some SQL stuff down here, and it throws an exception, and that has to be managed up here. So that I have some SQL stuff that is bleeding into my service layer, and they have to be separated. That's the intention. That's why we have the interface. So if, for example, I were to swap out for a different kind of storage, maybe just file, or it's a non-SQL, no SQL database, then there will be no more SQL exceptions. So I would have to rework the interface, and I would have to update my services because I swapped out of the database. So we want that flexibility. We just depend on the interface and have no idea what's going on beneath it, whether it is SQL or files or NoSQL databases like MongoDB or RavenDB or whatever. So I don't want to throw SQL exceptions up here. I will catch them right away, and then I will throw my own generic exception, which I can throw from any kind of data access layer. So that's why I have my where did it go? my data access exception. This one here. Okay, let's undo stuff, get back to the thing that is right. Okay, so separation between layers, we want to isolate them, we don't want anything detail implementation specific to bleed out into other layers like this. Maybe this exception contains more information than just the message here, so in that case I might at some point have to rework it. I can wrap exceptions into other exceptions. For example, if I say throw new runtime exception, I can provide it here with a throwable, so I could actually just give it this one. Now I'm throwing a runtime exception that contains the SQL exception, so the developer might get the information out if needed, but we'll keep it like this. This is at least the minimum required. And that's quite the detour, I think. What were we doing? I was about to test whether this actually works. So first, we have no users in my database. Let's give this a go. We run it. And it's compiling. Expected true, false. And what do we have? I do have one here. Okay, so this size thing might not be a good method to actually use. I guess that's what does it give me? That's 0. Okay, so what else can we have? Result set get size fetch size. It's also okay. Okay, so this doesn't really give me anything useful. Let us try. So generally, stop this. You want to use while because you get multiple rows, but in this case, I know I just get one. That's the intention of the. So else could just fail here. So if there's no next, okay, let's try this. Now I actually have two. Yeah, which makes sense. So I get the wrong user out. Okay, right, because I have 2 in here, so that's the 3 actually. So that's the part where I soon have to write a method that actually cleans up before we run the test. So this is the problem with, having a shared database. People are running all kinds of tests and interfering with each other. So you want to make sure that the data in the database is exactly as you need it to be. Okay, so now it succeeds. That's good. What if I just to make sure that my check actually works? Right. So at some point I sort of have to write a test to test that my test works. I guess you want to keep your test minimal. Okay, so I did fail down here. That makes sense. I am somewhat confident that the code now works. So if I run this, let's just do it again. I will get my run it. I'll get my username, my user object inserted into the database, and there we go. It's here. So, and if I run it again, obviously it will fail. So we don't want any dependencies between your tests. And now I have a failure because I'm getting the wrong user out, not the one that the one I just inserted is the one that is now on the second row here, but I'm retrieving this one. So before we want to do this cleanup here, and we say, I can probably steal some of this again. Yeah, in this case we just throw it because I can't really, if this fails then there's nothing else to do, and then the test should just stop. Okay, so the SQL is I need to delete from the user table everything. So let's go and say delete from with this stuff again. So I'm already regretting calling it user. User is also a bit, and I failed that, of a vague term. Everything is just a user. Maybe it should have been a developer or project member or whatever. Okay, there are no arguments. We executed, and I don't give any where clause, so we should just delete everything. And let's go again. Success. And let's just check here. I have my user, it's there. So previously, if I ran it again, I would get a new user and retrieve the first one and it would fail. But if I run it now, success again. And let's just see 3A5 and refresh. Now it's actually a different one. So I think I'm pretty happy with this so far. There's definitely some stuff here that I could, because I'm doing that multiple places. Alright, so let's just create a method for that. Get connection to test DB. And it recognizes that I have the identical code down here, so I said yes. So if I ever change this, I can just change it one place, that don't repeat yourself kind of thing. And probably okay, I don't want to catch anything in this cleanup. There's nothing to actually do if it fails, so I cannot recover in any way, so there's no need to catch the exception. I want it to fail hard. Catch. I don't want to catch anything here. I want it to throw instead. Add exception to method signature. Yeah, I want it to fail. But I still keep the try with the resource, because then once we exit this scope, which is here, then the connection is automatically closed. So I think I can do like close. You see, there's a close method, and maybe there's a flush. No, okay. But the close method will automatically be called once we get out of the scope where it is defined. So that's the try with resource. It's pretty neat. Alternatively, I had to go finally. Connection. No, I don't even have that reference. Maybe I can do it in here. Yeah, that close. So I have to do it manually, and it's just the same thing as doing it with the resource up here. So I'll keep that. It's simpler. Okay. Should have exactly one row in database. So I can insert a user into the database. That's pretty cool. I can clean up my database. Eventually, if I'm going to touch upon multiple tables, I'm going to have to expand upon my cleanup, but this is good enough for now. I should totally do this in a try with resource kind of thing, just to make sure the connection is closed, as I talked about. My expert colleague says this is a good idea, and I trust him. So that's what we do. Okay, so that's my first test. I can insert something. I'm not going to do all kinds of elaborate different types of users. That's less important for this kind of integration test. If I can insert one, then I can probably insert another. And every kind of incorrect data should definitely be caught by the service layer instead. So that is the create. Can I find a user? So now I want to find a user by ID. Here, maybe I want to do one or two tests So it is a bit elaborate. Okay, what do we have? We have test public void should return existing user. And just to make sure, remember stuff, arrange act assert. And the arrange, first I create a user. And I give it a random URL, and I give it a username, and I give it a password. Wonder if I have anything stored here. It's a long time ago. I just pick something from up here, right? Password. Okay. And again, we want to verify that I can get something back. So we say actual ID, actual username, and actual password. So it's actually pretty similar to what I feel like I did. Okay, so I insert stuff, yeah. And we act. So that means, no, the arrange, that means I also have to insert it. Okay, user DAO, I can just, use that method now because it works. So, and probably that is okay, but it sort of means that I depend on other stuff to work. So if I were to be strict about it, I should probably write my raw SQL like this. But maybe I don't want to do that. I mean, now I assume that the method is doing the right thing, but if it isn't, then I guess it fails, and then that should be okay. User DAO find by actual ID. That returns to me a retrieved user. So create a user, insert it, that's my setup. Retrieve that user, and assert, that means we say, I can probably do this. User retrieved user dot username, retrieved user dot ID, and retrieved user dot password. So we're asserting that the stuff on the retrieved user is actually the same as the one we inserted. Let's run it. Obviously it will fail because I don't have any method implementation for the find. Yeah, not found exception, cannot invoke get username because retrieved user is null. So this one is null. Yeah, makes sense. Does it? Find? Okay, return null. So that's the default implementation. So instead we would say try connection con equals get connection, and add cat clause, and here we say throw new data exception e-message like this, and in here I want to say I want to define my SQL, and we are retrieving something by the ID. I wonder how I match that. Probably going to be inconvenient that I decided to use some kind of object here rather than just converting into a varchar and then back again. We'll see how that goes. SQL, and we say select star from can I beautify it a little bit? No, not like that. Oh, maybe I can do it like, I think, yeah, okay. Java 15 feature, select star from, oh, this is neat. I never thought I'd use it. Select star from user where ID equals question mark. con prepare statement, and we use the SQL and give me a statement, and then statement we want to set an object. Okay. The first one is the ID. Very curious if this is going to work, matching the objects here. Let's see. We say statement execute query, and that returns to me that result set. And I'm looking for a single one, so we just go if result set next. And I already have this code, right? I just implemented that in my other test, so spin move right. It's up here, right? This. I get that out. And instead of that, I'm just going to return new user with ID, retrieved ID, and the retrieved username and the retrieved password. Maybe I don't have to call it this. I don't have any conflicts here. Use ID. Do I? Okay, that's an input. Whatever. Let's do like this. Prepare statement. Set the argument. Execute it. Get result set. If there is anything, we retrieve the 3 values and return a new user. And if there's nothing, how did my mock class work? Because I sort of defined how that should use mock find. Right, I didn't find anything. So if we get to down here, then I didn't find the user we were looking for, which is an obvious error. So let's see. Task.io, no. User server, where's my test? Did I close it? Probably. Yeah, user DAO tests. It's over here. Should return existing user, that's what we're working on. Just move it over here. Let's see, we give it a go. Man, it's green. I've asserted stuff. That's nice. This is going far better than expected. And then we just have one more thing. That is the update. Yeah. Let's do that one as well. So we say test public void should update user. And what do? We create a user. Well, first I need a user. Yeah. Arrange act assert. So I need a user first. And then the act part is to actually update that user. So we say, how do we do that? I create a user, updated user. Yeah. And we give it the same ID. We give it a new username. And let's just give it the same password. Okay, and that totally failed for me. New user. So if I hand over this user to my data access object, it should just look for this one, which should be there because I created it, and then override this. So we say user DAO update with my updated user. And assert, well, I need to retrieve it again. So let's just say user find. How convenient, I have all these helper methods by now. Retrieved user. And then we want to verify that whatever I have in here is the same as the updated user. So I need to verify the same, same values. I don't have an equals method, so I cannot compare the two. So I just copy this and we say this is the new stuff. So we say updated username. That's part of my range, I think. But I don't need these anymore, so let's just remove the bloat a little bit. And that one I need still, actual ID, yeah. A new username, let's move it down here. So that's the setup, this is what I'm looking for. Act. Yeah, we update it. Down here we say, what are we looking for? We're looking for the actual ID, retrieve user. No, I do that in the next one. So we say updated username, actual username, just to be consistent. And password, do I care about that? It shouldn't update anything, just make sure that it doesn't change. Here we say actual password. Alright, but that's the same thing, so we'll just put up here. Oh, I messed this up. Here we say username, and here we say password. So I have a user with some whatever username, we don't care about that. I have a password that should remain the same, and I have an ID that should remain the same. And we create it, and then I have the updated username. And then I find my user, and we compare the updated username to whatever was retrieved. Here. Because that's what updated, yeah. And actual ID is matching the retrieved one, and actual password is matching that one. So we run it, it fails because I don't have anything in the update thing. Multiple failures, expected new username, but it was right. So nothing happens, obviously. Oh, not that one. Update. Split and move right. And update. So we do something pretty similar. We say try, and we say connection con equals get connection. And that means I have to add a catch clause, yeah. And we'll just do this one. So update, I need to define an SQL string here, SQL. I like this now, that's pretty cool. And I need a con prepared statement with my SQL. Yeah, statement. And I probably need some arguments. We'll do that after here. Right, so SQL to update something. Alright, let's give it a go. Update and user set. I have columns. What do I have? I don't want to update the ID. I want to update the username. Should be equal to some argument variable parameter, and set password should be able to be updated also, like that. And oh, then I need a where condition where ID equals question mark. Okay, so that means I need to set what do I need to set? String. The first one is the user dot username statement set string. Then we have the second one, this user get password, and statement, the third one, set object, third one, user get ID. Yep. And we say statement execute. Probably good. Should update user. Let's see what happens. Do I have? Obviously I don't have anything here. Well, I have one from the last time, but that's been cleaned out. Syntax error at or near password. And the set shouldn't be there. Let's go again. And now it's green. Okay. Should update user. So I have my accept the find username and delete. But I think that's enough for now. You can sort of get the idea, I hope, that I have my tests against the database. I have my test database. I call it database all the time, but it's basically just a schema. And then I have the DDL here, and I would create the and I could create my production like database, and then just set the correct schema, and then whenever I need to update something, I could work against those two. So next time, add user table, task table, I guess, and here add password to user table. So you can sort of keep track of these whenever you create a new version. Each of the students in your group would just set the, run this one, no, not that one, set schema test, and then execute the latest version, basically compared to what they have. Maybe we should have like a version table also, and then each of these would then update the version. Then you can always see which version yours are at. Add task table, add version table, create table version. Fine. Oh. And here you just have an ID, serial, primary key. Oh, I forgot primary keys on here. This is obviously the primary key in the database. And varchar, version varchar. And so if I had something like this, then every time I create a new version, I could just update my version. Interesting. We'll see if I do that at some point. But I think that's it for this video. It's becoming quite long because I fumble around. That's how it goes when you try to free flow stuff. My tests are slightly more elaborate now. I mean, I could obviously rework this one because I could use the find method, but I think I'll leave it as it is. And I have my cleanup database every time, so that's pretty good. My user postgres DAO takes the argument of where to connect to. So when I run my server, I can just provide it with a different connection string to the production database. So that's pretty neat. And then we would create similar tests for the task DAO implementation eventually, perhaps. And that's probably not. I'll do that later. I think the next video will be about trying to add a server and do tests from that. So basically from the socket server all the way down to the database. See how that works. That's almost an end-to-end test of the server, at least. That's going to be fun. So that's the next video, and thank you for watching.